Hello dear student, welcome to my YouTube channel. In this video we will see assay of sodium chloride. So how to calculate a factor for assay of an sodium chloride. So we will see that. So for calculation of an factor, you should know the reaction very firstly. So in the reaction, sodium chloride, it reacts with an silver nitrate and it forms a precipitate of an silver chloride plus sodium nitrate it forms. So this reaction is naturally balanced. It means that there is no need to balance this reaction because it is naturally balanced. You can see sodium it is 1, here it is also 1, chloride it is 1, chloride is also 1, silver is 1, nitrate is 1 and nitrate is 1 over here. So all the elements are exactly similar on the left and right hand side. Now further, see in the burette it contains an silver nitrate solution. Silver nitrate, it means it is a titrant, and analyte over here, because we are calculating for sodium chloride assay. So analyte here it is sodium chloride and it requires plus K2Cr2O4. That is an indicator, potassium chromate. So for factor calculation, once we know the reaction, now this reaction it means that 1 mole of AgNO3 it is equivalent to 1 mole of sodium chloride. 1 mole, and here also 1 mole. So 1 mole from each side it has been required. Now further we have to calculate and molecular weight of both the species. Molecular weight of silver nitrate it is 169.9 gram, which is equivalent to 58.4 gram of sodium chloride. Means 169.9 gram will neutralize 58.4 gram of an sodium chloride. So this much amount of an analyte and titrant is required for a complete reaction. Now further, see, we have to use the concept of molarity over here. Molarity means it's a total molecular weight. So molecular weight, it is dissolved in 1000 ml of an solvent. So that will give 1 molar solution. Means what? 169.9 gram, when we dissolve in 1000 ml, it will provide 1 molar solution. So here I can write 1 molar AgNO3 and that is 1000 ml. So this quantity it means this much. It is 1 molar solution in 1000 ml and that will neutralize 58.4 gram of an sodium chloride. Now further we have to calculate a factor. So for a factor calculation, see, we have to calculate for each ml. So here you can make a cross multiplication. 1000 ml, it will dissolve, it will neutralize 58.4 gram of sodium chloride. So we have to calculate for 1 ml. So for calculation of an 1 ml, take it x. So x it will be multiplied with 1000 and 1000 it will get divided and 1 it will be multiplied by 58.4. So the answer for this you can directly calculate also. See, there are 3 zeros. So take this decimal on this side by 3 0. So 0.0584 gram. So you can see I have shifted this decimal 1, 2 and 3. So these are 3 and I have shifted over here because it has been divided by 1000 of NaCl. So each ml means 1 ml. So I will rough it, each ml of AgNO3 will neutralize this much amount of an sodium chloride, and that is 1 molar. But now we have to calculate, as per the assay, we have to calculate it for 0.1 molar. Again you can do a cross multiplication. If 1 molar is giving this much, So how much it will give for 0.1 molar. So very simple is that shift this decimal by 1 point. Here I will write instead of 1 I will write 0.1 molar. So I will shift this decimal, I will write one more 0 in between. 58.4 gram of sodium chloride. You can do this cross multiplication very easily, and again I can write each ml of AgNO3, that is 0.1 molar. It neutralizes this much amount of an sodium chloride. So this factor you can utilize for an further assay calculation. So thank you for watching the video. Stay tuned for more videos.